Okay, in this video we're going to talk about the graph of a function. One thing we need to know is the vertical line test. It says that if every vertical line intersects a graph in at most one point, then the graph is a function. So, for example, this graph would be a function because no matter where I draw a vertical line, it would only intersect in one point anywhere. However, this graph would not be a function. Also, circles are not functions. So if I'm anywhere to the right of the y-axis and I draw a vertical line would intersect the curve in more than one point. Find the domain and the range of the function. So I've got a half of a parabola kicked on its side, facing towards the right, and the domain is the set of all x such that x is greater than or equal to -4. So if I'm at 4 or bigger, at -4 or bigger, and I look basically above, I'll be on the graph. The range is a set of all y such that y is greater than 0. So if I look at the y-axis, then anywhere that is 0 or bigger, because I don't have any graph in quadrants 3 or 4, okay, anywhere that's 0 or bigger puts me on the graph. The next one, same thing, state the domain and the range. The domain is set of all x such that x is between pi and -pi, including the values. So pi is 0 and -pi is 0. We'd be between those two numbers. The range is the set of all y values such that y is greater than or equal to 1 and greater than or equal to 1 or -1, or greater than or equal to 1. So y has to be between 1 and -1, in other words. If I look to the left and to the right, I'm going to be on the graph in that part of the range. Okay, there's a problem in the book that I liked. This is on page 76. So use the given graph of the function to answer parts A through F. Hopefully we can see that. Part A, f of 0 and f of 6. F of 0 is asking for the y value when x is 0. So when x is 0, y is 0. F of 0 is 0. F of 6 is 0. Okay, f of 2 and f of -2. F of 2 is -2, and f of -2 is 1. Okay, is f of 3 positive or negative? Okay, well here's f of 3, some negative number. Of course, if I'm above the x-axis, then f is positive. Okay, so f of 3 is going to be down here somewhere. F of -1, -1 is right here, and I'm above the x-axis, so I'm positive. Okay, for what values of x is f of x greater than 0, or equal to 0? It looks like at 0, 4, and 6. For what values of f of x is f of x less than 0? From between 0 and 4, f of x is less than 0. Part G, what is the domain of f? It'd be the set of all x such that x is between -4 and 6, including -4 and including 6. Okay. What is the range of f? The set of all y such that y is between -2 and 3, including -2 and including 3. What are the intercepts? Okay, well, the intercepts are the points when y is 0. So this is really the same question as part E. 0, 4, and 6 are when y is 0. And what is the y-intercept? Well, there's only one point where we cross the y-axis here, is that 0, 0. So 0 is the answer. Let me see here. So part K, how often does the line x equal, or y equal 1 intersect the graph? Okay, well, y equal -1 is right here. It looks like it's going to intersect the graph twice. How often does the line x equal 1 intersect the graph? X equal 1 is this line right here. That's going to intersect once. Okay. So M. For what value of x does f of x equal 3, or y equal 3? Well, x equal 5 means that y is 3. Okay. For what value of x does f of x equal -2, or y equal -2? 2. Okay. So problem 28 is an example of a problem that you'd see in this section. Problem 28, we've got f of x equal x squared plus 2 divided by x plus 4. Okay, and I've got that one here. Problem 28, is the point 1, 5 on the graph of f? Let's see here. So if x is 1, 1 plus 2 is 3, 1 plus 4 is 5, 3 over 5, yeah. So that point would be on the graph of f. If x is 0, what is f of x? What point is on the graph when x is 0? Well, when x is 0, we get 1/2. 0, 1/2 would be on the graph. If f of x is 1/2, what is x? What points are on the graph of f? So if y is equal to 1/2, I'd set the function equal to 1/2 and solve. I cross multiply this. 2 times x squared plus 2 is 2x squared plus 4. And I get everything on the left. The 4 is canceled. 2x squared minus x equals 0. Means that x isn't common to those two factors. I can factor that out. X times 2x minus 1 equals 0 means that x is 0 and x is 1/2. So the points 0, 1/2, and 1/2 be 1/2. Those points are on the graph. Okay. And part D, what is the domain of f? Okay, well, the domain is all the numbers that are going to make y not equal to 0, or y involved in the domain. In the denominator, I know I can't divide by 0. x can't be negative 4. Let's see here. Part E lists the x-intercepts, if there are any, of the graph of f. So the x-intercepts, I need to let y be 0. And when I set y to be 0, x squared plus 2 divided by x plus 4 equals 0. If I multiply both sides by x plus 4, then x squared plus 2 equals 0 means that x squared equals negative 2. And that's going to have no solutions to it, seeing as though x can be anything, and if x is anything, x squared won't ever be negative 2. Okay. List the y-intercept, if there is one, of the graph of f. The y-intercept, so if I let x be 1/2, or if I let x be 0, y is 2/4, and that's 1/2. 0, 1/2, and that's a point that I've already got listed here. Here's f of 0. 0, 1/2. Okay, that's the y-intercept. The y-intercept is found when x is 0, of course, we know that. Okay, so problem 44 is the last one they had in this section. Match each of the following functions with the graph that best describes the situation. Part A, the temperature of a bowl of soup as a function of time. Well, the temperature of a bowl of soup. The temperature of a bowl of soup I know is going to decrease over time. So 2 would be that answer. The number of hours of daylight per day over a 2-year period. 2 years. Well, I know the axis is not straight up and down, right? It's tilted. So some days are going to have more light than others. And it looks like I'm looking at a graph kind of like this. Problem 5. Graph 5. The problem C, the population of Florida as a function of time. Florida is an exponential function, and that would have an exponential growth model. So graph 4. The distance traveled by a car going at constant velocity as a function of time. Okay, constant velocity gives that away. We have a constant velocity here, y equal x, for example. The height of a golf ball hit with a 7-iron as a function of time. A. The height of a golf, so graph 1, for example, would be that that model. Okay, and oops. Okay, so the homework is on page 76. Here's the problems that I wanted you to do, and that is all done with that section.